All right, today we're going to be looking at, let me see if I can make it a little bit brighter. That's better. Today we're going to be looking at sequences, and we're going to start a new unit that has all to do with sequences and series. We're only going to spend one day on sequences. I just want you to remember what a sequence is. You did not look at sequences in AB, so this is a new topic. You looked at them, I think, in pre-cal. At least you used to. I'm not sure anymore. But basically, a sequence is a list of numbers in a particular order, and a lot of times there's a pattern to the numbers. Terminology: A1 would be the first term in the list, A2 would be the second term, A sub n would be the nth term, and then A sub n plus 1 would be the nth plus 1 term. So on this first one, all we want to do is practice writing out the first 5 terms. So A1, we're going to take 1 and just think about this as your formula. We're going to plug in. So 1 plus 1 is 2 over 1 squared is 1. So that's going to be 2. And then A2 is going to be 2 plus 1 is 3 over 2 squared, which is 4. And then A3 is going to be 3 plus 1, which is 4 over 3 squared, which is 9. And A sub 4, 4 plus 1 is 5 over 4 squared, which is 16. I think you get the idea. We'll just stop there. Okay. Now, here are those as ordered pairs. So the first number is going to be the term number, what number it is in the list, like the first, the second, the third, the fourth. And then the second number is going to be what the actual value of that term is. So the way you would read this ordered pair is the first term is 2, the second term is 3/4, the third term is 4/9, the fourth term is 5/16, and the fifth term is 6 over 25. We didn't actually find that one. So basically, if you were to plot on an XY grid, the X would be the term number, and the Y would be the term value. And so it ends up looking like this. Now, these are all going to be discrete points. We do not connect the dots because when we're dealing with sequences and series, we do not have in between values. So our values for our domain are all integers, 1, 2, 3, 4. In fact, they're all really natural numbers. All right, so what do you think the terms of this sequence are all starting to look like as n gets infinitely large? So as our term numbers go down the list, what is our term value starting to look like? And you can tell pretty quickly that it's going to start looking like 0. So what we would say then, if the terms of the sequence are all starting to look like the same number as n gets infinitely large, then we say the sequence converges. Okay, here I'll use, do I have a highlighter? I'll use a highlighter on it to let you know. So we say if all of the terms are starting to look like a single number, the same number, then we say it converges. If the terms are getting infinitely large in either direction, we say it diverges. Now, that can also be not only infinitely large, but also, oops, let me put an or, oscillating. Then we say it diverges, okay? So basically what we're doing is we're doing the limit of the term values, and we're looking to see what that limit is going to. So that's how we're going to approach these problems. So if we have the sequence 2 plus n, then when we graph this, and this is what you're going to have to do on your homework, if we start at, this is our starting value, so if we start at n equals 1, 2 plus 1 is 3, so we're going to put that as a dot. 2 plus 2 is 4. 2 plus 3 is 5. 2 plus 4 is 6. 2 plus 5 is 7. 2 plus 6 is 8. 2 plus 7 is 9, 2 plus 8 is 10, 2 plus 9 is 11, and 2 plus 10 is 12. So here's what it all starts to look like, and obviously these are going off towards infinity, so we would say that this series, or this sequence, diverges. Okay, if we look at this guy, now our starting number is 0, so we're going to actually put our first dot on the y-axis. If we plug in 0, we're going to have 1 minus 1/2 to the 0 power, which is 1. So 1 minus 1 is going to be 0. If we let n be 1, we're going to have 1 minus 1/2, which is 1/2. So that would be 0.5, wherever that is. There we go. If we have n equals 2, it would be 1 minus 1/4. At this point, I'm going to start getting onto my calculator. So 1 minus 1/4 would be 3/4, so 0.75. So about right there. 1 minus 1/8, again, is 0.875. That would be for 3. So almost to 0.9. Then 1 minus, let's see, it'll be 0.5 raised to the 4th power, because we're on 4. So 0.9375. And I'm just using my calculator. 0.9 is right there. And so you can see on my calculator, I'm just going to copy and paste this guy and change this exponent each time. So 0.9687. And as I continue doing this, you can see that I'm getting closer and closer to 1. 0.992. And this is what you're going to have to do on your homework. So it is a little tedious, but I need you to be able to recognize what it means to come up with the terms of a sequence. Oh, I've lost myself. Where am I? There I am. So 9. 2 more. 0.998. And then 1 more to the 10th. 0.999. So if we look at this guy, I would say that as we continue to go further and further out, it's going to converge to the number 1. Okay. All right, for the next guy, we have -1 to the n power. So this one is going to be pretty easy. If we start with 0, -1 to the 0 is 1. If we let n be 1, -1 to the first is -1. -1 squared is 1. -1 cubed is -1. -1 to the 4th is +1. -1 to the 5th is -1. And we're just going to be bouncing back and forth because our sign is just going to change. And that's important that you recognize that -1 to a power, all it really does is alternate in sign between -1 and +1. It is not like an exponential growth problem. It does not grow, it does not decrease, okay? All it's doing is alternating in sign. Now, because we are alternating back and forth between two numbers, we would say this sequence diverges. Okay, if we do this one, -1 over n, if we start at n equals 1, it would be -1 to the first, which would be -1 over 1, so it would be -1, so it would be down here. If we let n be 2, it would be -1 squared, which would be 1 over 2, so +1/2, which would be right there. Then we would plug in a 3, so that would be -1/3. So that would be -0.333, so about right there. Then it would be +1/4, so 0.25. Then -1/5, so that would be 0.2, -0.2. Then +1/6, so I don't know what 1/6 is. 1/6 0.1666, so almost a 0.2. And then 7, what's 1/7? 0.142, now it's going to be negative. So it's about halfway there. And then, let's see, 1/8, 0.125. Oops. That's going to be right there, a little bit over 0.1. All right, and then 1/9, I think, is 0.11111. That one's going to be negative. And then 1/10 would be 0.1, and that one's going to be positive. And so if we look at this, it looks like, yes, we are alternating. We're alternating, but we're coming closer and closer to 0. So this one is going to be an alternating series that actually goes to 0, or a sequence that actually goes to a number 0. All right, now we don't want to continue doing this over and over again because, like I said, it is a little tedious. So what we're going to do is we are going to use limits to determine if it converges or not. So a sequence will converge if the limit as n goes to infinity is equal to L, where L is any finite number. A sequence will diverge if the limit is positive or negative infinity, or does not exist, okay? So we'll diverge if we're positive or negative infinity or does not exist. So we're going to use our rules for limits at infinity, which, remember, are top heavy, bottom heavy, and equal. So we're going to use that to determine whether our series converges or not. So if we look at this guy, we're looking at the limit as n goes to infinity of n over n plus 1. If we do our top heavy, bottom heavy equal, we're looking at an equal series, a sequence, and so our limit is going to be 1. If we look at this guy, the limit as n goes to infinity of 1 over 2 to the n. Now this guy, the bottom is going to become close to infinity while the top stays 1, so that one's going to go to 0. It's bottom heavy. For this guy, if we look at the limit as n goes to infinity of 3 plus negative 1 to the n, if I think about this, remember the negative 1 to the n is going to alternate in sign. It is not going to grow towards infinity or towards negative infinity. So if I think about writing out my terms, when n is 0, it's going to be positive 1, so 3 plus 1 makes 4. When n is 1, it's going to be negative 1, so 3 minus 1 makes 2. Then when n is 2, it's going to turn back positive, so we go back to 4, then it's going to go to 2, and then it's going to go to 4, and it's going to continue that cycle. So that means this limit does not exist. I should have said these converge. This converges. Now, normally when we say it converges, we give what it converges to, and that's implying that the series converges. Since this series, the limit does not exist, we say the series diverges, and we don't give a value because it doesn't have a value. All right, this is also sequence notation. It's just a sub n is your formula. It's like your f of x. So if we look at the limit as n goes to infinity, and we just put in our a sub n, so we don't have to write our formula. This guy right here, if I look at dominant term on top and dominant term on bottom, it's going to be 0 minus, if I look here, dominant term on top, dominant term on bottom is going to be 3. So then we are going to converge to negative 3. And again, most of the time you don't have to write converges, but let's go ahead and write it anyway. All right, for this, we are going to do the limit as n goes to infinity, and this is one of the limits that I'm asking you to memorize. This limit goes to e cubed. It's on your formulas and justifications. So if it converges to a number, no matter what it is, then we say it converges. Or if the limit gives us a number, no matter what, then we say it converges. All right, for this guy, if we do the limit as n goes to infinity of a sub n, we have, it's top heavy because this guy is going to go off to infinity while this guy stays between -1 and 1. So actually what it's going to end up doing is oscillating between positive and negative infinity. So if it oscillates between positive and negative infinity, then it doesn't exist. So we say it diverges. So we're just using our top heavy, bottom heavy equal to look at our limit as n goes to infinity. And that's all we're working at today. So if you have any questions, come see me. Bye, guys.